So if I gave you this and said, find a derivative of this, it is a product. And if you look at this, you're thinking, well, I could learn some new thing called the product rule, or there's another alternative, right? Okay, let's see, it all comes from 3 to 4 and ask. Come from 3. Okay, no problem. Yeah, no problem. All right. So one of the approaches to handling something like what you see on the screen is to multiply it out, right? If I multiply this out, so distribute this, in other words, into the bracket, right? And I would end up with, you're adding your exponents, as you know. That would be 4x7 plus 2x cubed minus x squared. Okay, I'm sure you can all agree with that, right? So 4x7, I add those exponents, the 5 and the 2. The 2x cubed, I'm just adding the 2 and the 1, and then the minus x squared. That's the same function. All I did is I just simply expanded it. So using the dy dx from yesterday, then that would work out to, follow along with me here, 28x6, multiply the 7 and the 4 and drop the exponent by 1, plus 6x squared minus 2x. So there's our answer, right? That's the answer, plain and simple. And that's all I really needed to do was just simply expand it, and then I would apply the normal product laws to working it out. But what if it looked like this ugly monster right here? So now we're talking about one bracket that has 1, 2, 3, 4 terms, another one that has 3 terms. If you multiply a 4-term polynomial by a 3-term expression, and I say expression because it's not really a polynomial, it has a square root of x in it, you're going to end up with 12 terms, 4 by 3, 12 terms. Then you have to simplify that, put your like terms together. I don't know about you, but I don't want to do that, right? I certainly don't want. If there's another way, I certainly do not want to do that. So one approach you could take is it possible that I could just multiply the two derivatives together and see if that works? So x to the power of 2 times x to the power of 3, well, we all know that's the same thing as x to the power of 5, right? So these two functions are equivalent. Let's accept that. So what if I were to take x squared and derive it? So that would be 2x, right? That's my dy dx for the x squared. And then that would multiply it by 3x squared, right? Right? That would be the two things together. So if I multiply these two, I would end up with what? 6x cubed. Right? So one approach would be to say, let's take each of these two things and derive them separately and then multiply the result together. But is that the same thing as if I were to derive the equivalent x to the power of 5? Well, no, because dy dx of this would be equal to 5x4. This is not equal to this. They're not the same. So one has to be right and one has to be wrong. It turns out that the one that's wrong is this one. You can't take the approach of the two derivatives and multiply those two together. So the product of so what we're saying, the conclusion to that is that the product of the derivatives does not work. Is not the approach. It's not the right approach. Okay, so what is the right way then? That's the question. That takes us to the product law or product rule. Product law says, or product rule says, if I give you a function that was a product of two other functions, so there's an f of x and a g of x, where f of x and g of x are both differentiable. So remember that there are functions that you may have some issue with at certain points in trying to differentiate them, but these are differentiable functions. Then the product law says you take the derivative of the first one, which is this, f prime x, remember, is a derivative of the first function, and multiply it by the underived second function, right? So you take the product of those two things. The first one is derived, so I'm going to derive the f of x, and I'm going to multiply that by the underived second function. I'm not going to do anything to the second function. Then I'm going to flip that around. I'm going to take the first function and not derive it. So this function is now not derived anymore. Then I'm going to multiply it by the derived second function. Then I'm going to sum those two things together. That's what the product law says. So we're going to do this question again, but using the product law, right? So the first time I did this, I said, okay, why don't I just multiply it all out? And if I multiply it all out, I get a regular polynomial. I can just take the root of that polynomial. But now I'm told that there is a second approach called the product rule. So what I'm going to do is I'm going to try this product rule out. So the product rule says take the first function and derive it. So if I derive 4x5 plus 2x minus 1, so my dy dx, in other words, right, should be equal to the derived first function, which would be 20 x4, 5 times 4 is 20, then drop a degree, plus 2, right? That's the derived first function multiplied by the underived second function, which is just x squared. Plus, I'm going to go down to the other line to do the other one. Take the derivative of the second function, which would be 2x, and multiply it by the underived first function. So we're not doing anything to the first function. So it's 4x5 plus 2x minus 1. Right? So let me go with that one more time. Take the derivative of the first function, derivative of this function here, multiply it by the underived second function. Right? So I don't do anything to the second function. Add that to the derivative of the second function times the underived first function. Now, you're thinking, I don't know, that doesn't look like the one we had before. Right? When we did this before, we got 28 to the x to the power of 6 plus 6x squared minus 2x. That doesn't look like what this is. Right? That looks like a different answer. Well, let's find out. Let's multiply this out now. So this would be 20x4 times x squared, which would be 20x6 plus 2x squared. Right? So I multiplied this by both those terms, plus the 2x times the 4x5, which would be 8x6 plus 4x squared minus 2x. Okay, so all I've done is I've taken the 2x and multiplied that into the second bracket. So that would be, as I said, 8x6 plus, what is that? I'm just checking for x squared. I'm not sure if I made a mistake, so I pointed out already anyway. Now let's put our like terms together. There's a 20x6 here and an 8x6 here, so that'd be 28x6. All right, I'm just going to cross things out as I simplify them. There's a 2x squared and a 4x squared there, so that will be plus 6x squared. All right, so I can cross this out, and then there's a minus 2x. Let's compare this to our previous answer. Oh, look at that. All right, exactly the same answer, but using a different approach, using the product law approach. Same 28x6 plus 6x squared minus 2x. Okay, and the point is that whereas I could have just simply done this question on this page by multiplying it out, if I asked you to find a derivative of another one, well, I showed you before, find a derivative of this thing here, using the multiplication, sort of expanding it out, that's going to take forever because you're going to have 12 terms to play with at that point. So who wants that? Nobody wants to do that kind of work if there's an alternative. So I've demonstrated to you that there is a shorter method. Now let's try that on this question, and also go further and answer the question as to where the equation of the tangent line when x is equal to 0. So let's go through this process. So remember, I'm looking for my f prime of x, right? That's the same thing as dy dx. So that's going to be equal to the first term or the first function derived, which would be 6x plus 2 times the second function underived. So that would be 5x squared plus 3x plus 8 plus I'm going to do the other way around now. I'm going to derive the first function, the second function, which would be 10x plus 3 times the underived first function, 3x squared plus 2x minus 4, right? This is supposed to be a plus here. Let me just move that up a little bit. Okay, so that's the sum that we would use to represent the derivative of this function. Let me just go over that again. Derive the first function, and I'm not just going over it again. I'm trying to make sure I didn't make any mistakes. The first function, the 3x squared plus 2x minus 4, that'll be 6x plus 2. The second function is not going to change. 5x squared plus 3x plus 8, that's still there. Then I reverse that. The second function derived, which is 10x plus 3, times the first function underived. Now, you could say, that's a lot of work for me to multiply this out, but the question does not require you to multiply it out. Right? The question is requiring you to find the equation of the tangent line to the curve when x is equal to 0. So I'm going to leave the function exactly as it is. Right? I don't really want to have to multiply this out if I don't have to. The question didn't ask me for the derivative in its simplest form, then why go through that, right? If I can use it as it is right now to answer the actual question, I'm going to do that. So this says find the equation of the tangent line to the curve at the point where x is equal to 0. Okay, so why don't we, well, how do we do that? Right, let me get some ideas, some thoughts on how we can find that tangent line. This is exactly what you had as homework last night. All right, how would I find that tangent line? What would my next step be to find that tangent line? Come on, let me get some help from the class on this one. Where do I go for plugging 0 in to find the slope? Thank you very much, Taj. And thank you very well. We're not ready for the y equals mx plus b yet. We will. But the first thing is that we need to find the slope. Look at what Taj said. Taj is right. Right? What is the slope when x is equal to 0? Well, our derivative function will tell us that. That's why we have a derivative function. So I'm going to find the f prime of 0. I'm going to plug 0 into this ugly monster here. Well, luckily for us, because it's 0, that's going to just leave us with 2 times 8, right? Because all the terms with x are going to disappear, plus 3 times minus 4, right? All the terms with x are disappearing, right? So that leaves us just with the constants. So that's going to be equal to 16, what is that? Minus 12, which is 4. Hope I did that right. Let me just double check. 16, where 3 is 12, 16 minus 12, yeah, it's equal to 4. So now we have the slope of the tangent line that we need when x is equal to 0. But Cauchy says y equals mx plus b, fine. But what else are we going to need for that y equals mx plus b? What else do we need? Yeah, a point. Thank you, Adam. Where are we going to get that point from? Right? How do we get the actual point on the line? Because we need a point on the line, right? What are the coordinates of that point? Plug 0 into the original. Thank you very much. Thank you, Sarah. Thank you, Ashvan. And thank you, Ariane. I'm going to plug that 0 into the original function. So it's not the f prime of 0, it's the f of, sorry, and I'm putting f prime down. I don't know why. So let's erase that. All I need is the f of 0. F of 0 means put 0 into the original function. The original function has all these x's in it, so really, it's just multiplying minus 4 by 8. Okay? Because all the other terms with the variables are going to disappear. And that's equal to minus 32 by my mental math. So here's the point that we have. We have a point on this line, on this original function, at 0, minus 32, right? And the slope at this point of contact is equal to 4. So now we have what, when I asked the question earlier on, and I was told that by Cauchy I should use y equals mx plus b, I'm going to use y equals mx plus b now. So that means that the y value is minus 32 is equal to an m of 4 times 0 plus b. Okay, well, that's not so hard. That means that b is equal to minus 36, I believe. Yes, minus 36. So take the 4 from the two sides. So here's my equation of this tangent line. Y is equal to 4x minus 36. 4, what did I do wrong? Did I do something wrong? 4 times 0 is 0, yeah. So, yeah, you're right. So it's just 32. Thank you. I don't know when 4 times 0 ever became. Yeah, thank you very much. Thank you very much. Yeah. Yeah, again, I'm not doing this on purpose. I'm just messing up. That's just plain and simple what it is. So this is not right. This is wrong. So that means that D, let me fix this. Thank you very much, is equal to minus 32. I know, yes, I really am not doing this on purpose. And then the 36 should become 4x minus 32, which makes sense because this is just the y-intercept of the function, right? Thank you, thank you, thank you, thank you. Yes, that was a good catch there. All right, all right. So thanks to Kushi, Adam, and Sarah. Well done. Okay, I hope that question made sense. And there's another thing I just want to mention. If the question is not requiring you to give the derivative in simplified form, then why would you? You just need to use it for the question that's being asked. The question is being asked is for the derivative, sorry, for the tangent line, the equation of the tangent line. And this is a matter of plugging 0 into the derivative and then figuring out what the point is on the original line and going from there. Okay? All right. Let's try this again on a different question. Let me see if I left anything out of this page, by the way. Hang on a second. No, I didn't. All right. Find the x-coordinates of all points on the curve of the function below where the tangent to the curve is horizontal. So let me go through that with you. I'm going to go ahead and use that same power rule again. Not power rule, sorry, the product rule again. So my f prime of x would be equal to the first function derived, which is 2x minus 2, multiplied by the second function underived, 2x minus 1, plus, I'm now going to take the second function derived, which is 2, and multiply it by the first function underived, 2x squared minus 2x minus 3. Okay? Now, what do I need to do next if my goal is to find where the tangent to the curve is horizontal? A horizontal tangent has what kind of property which is important for us to sort of apply in this case? What's the important property of this horizontal tangent? Constant has a slope of 0. Thank you, Adam. Horizontal means the line slope is 0. So we'll set the equation equal to 0. So Taj and Adam, well done. Right? So constant, okay, let me just address what Shashti said. I know what you mean when you say constant. I think you're talking about, like, for instance, where the rate of change is 0, which is kind of what you mean, I think is what you mean. And yes, but the actual value of that slope when the tangent is horizontal is 0. And that's what we're going to use here. So in this case, unfortunately, we have a little bit more work to do because we will have to multiply this one out so that we can do what Adam and other people are suggesting, Taja are suggesting, about trying to see when you set it equal to 0, what are the x values that will make that happen. So let's go ahead and do that. So let's do a little filing here. So 2x minus 2, okay, so that would be, so f prime of x should be equal to 4x squared, and then minus 2x, and then minus 4x plus 2, and then plus 2x squared minus 4x minus 6. I'm sure if I made a mistake in that, somebody's going to point that out. I'm just going to read it through one more time, make sure if I might see for myself there's a mistake. 2x times 2x, 2x times that, minus 2x minus 4x plus 2, 2x squared minus 4x. Okay. Do I get the thumbs up on that, folks? Because I know some of you are so on top of things that you would spot the error if I made one. We're good? Okay, sounds like we're good. All right, so let's collect our like terms now. So that would be equal to 6x squared. All right, I'm just going to cross stuff out as I eliminate them. Then I have a minus 2x, that's a minus 4x, and a minus 10x, I believe. I think that's minus 10x. Okay, so that's this, and this. And then 2 minus 6 would be minus 4. Okay. All right. Okay. I don't know what to do now. You said something about setting it equal to 0. So I'll do that. But what do I do to solve for x? It's I think that's a pretty straightforward thing that we need to do. Factor it, absolutely. But before we factor it, or as part of the factoring of it, actually, there's a common factor right now, right? And that common factor would be what? What's the common factor right now? It's actually 2. So let's just factor out that common factor. So 2 bracket x squared minus 5x. Sorry, that's wrong. That's wrong. Before anybody even tells me it's wrong, I know it's wrong. Let's try that again. 2 times 3x squared minus 5x minus 2. Okay? Now, here's the thing. Because it's equal to 0, and because this is a product, I actually can divide both sides of this equation by 2 and not affect my solution at all, right? So in other words, this side is still going to be 0, and this side would just be left with the 3x squared minus 5x minus 2. Okay? All right, it does not affect even though this 6x squared minus 10x minus 4 is not the same thing as 3x squared minus 5x minus 2, the solution for the equation, where you set it equal to 0, is the same, right? There will be two different graphs on a graph, if I were to graph them, but they'd have the same zeros. They would still go through the x-axis at the same place. So I'm going to do exactly what you just saw in that video, right? I'm going to set up my little magic X on the side here and go through the process. So 3 times minus 2 is minus 6, and then minus 5 down here. I'm looking for two numbers now. Can you help me out with that, please? I'm looking for two numbers now that will multiply to give me minus 6 and add up to give me minus 5. So 1 and minus 6 I'm hearing. So 1 and minus 6, and I agree with that. And what you saw Nancy do, her name is Nancy, is divide both sides by the leading coefficient of 3, right? And then reduce it down. This one cannot be reduced down, but this one can. So that's going to go down to 2 over 1, minus 2 over 1. Okay? So the factors of this would be bottom number times the x, so 3x, and then plus 1, because that's a plus 1. Bottom number, which is x, or just 1x, minus 2. Okay? And what you heard her saying a while ago was that you can multiply it out and see that it actually comes back to what you wanted it to be, which is the 3x squared minus the 5x minus 2. Okay. So if this is equal to 0, then using the zero product law, that means that x is equal to minus 1 over 3 and 2. Those are the two values that would give us a horizontal tangent, right? That's if I were to draw this. In fact, when we start looking at maxes and mins in more detail later on, I'm going to say that this function is going to have a max or a min at these points right here, at minus 1/3 and 2. Okay? So far, so good. You know, I like to do my little room check-in. Adam, how about you? I know you're usually quite on top of things. Adam, are you there with us still? Perfect. Okay. And how about Fernando? Fernando, are you with us there? Is this making sense? Perfect. And one more little shout out. Sarah, how about you? Are we good, Sarah? Excellent. Okay, good. Well, what happens if I have a triple product? Uh-oh. What happens if I'm multiplying three things, right? Then what does dy dx come out to be, right? If it does 2, then that doesn't seem too hard. We just learn how to do that. What happens if it's just three things being multiplied or four things or whatever? What if there's a whole bunch of products? Well, it is what you think it is, right? Or hopefully what you think it is. What that would work out to be, for this particular case here, it's a pretty long solution, would be equal to the first term I would derive it, which would be the 2x plus 2 multiplied by the underived second and third. So 2x plus 5 and 2x cubed plus 7x squared. Plus, take the first term and not derive it, which would be x squared plus 2x, multiplied by the second term derived, which would be just simply 2, and then the third term underived, so 2x cubed plus 7x squared. Plus, you can see where this is going, hopefully, the first term underived plus the second term underived plus the last term derived. So 6x squared plus 14x. So a triple product like this would end up with kind of a mess in a sense, right? Because now you have to take one term at a time and derive it and leave the other two underived, and keep doing that until you've derived one of each of them and leaving the others underived. So hopefully that process makes sense, right? So that's what we call a triple product, right? You're multiplying three terms, and this could get messy. This could get really messy. There's another shortcut coming up though, but before we get to that shortcut, I'm going to sort of show you why that shortcut makes sense. What if it was a triple product, but it was a cube, meaning if it's a triple product where all the terms are the same. So here's an example of what I mean. The function is 3x squared plus 5x to the power of 3. So what would happen is the following, right? I'm going to take the first term and derive it, which all of them are the same. So I'm going to have 6x, right, plus 5. I'm going to multiply that by the underived term, which is going to be squared, right? Because I'm going to have this term twice. I'm going to have the 3x squared plus the 5x to the power of 2, right? Because remember, okay, let's write it out, because I'm not sure that that is very clear. I'm not sure that is very clear. Let me erase that. I want to make sure everybody's clear on what we're saying here. What I really have is this, right? My y is equal to 3x squared plus 5x times 3x squared plus 5x times 3x squared plus 5x. That's essentially what I have, right? Something cubed means I'm multiplying it by itself. But when I look at how that would turn out, I would get the 6x plus 5 multiplied by the underived other part. And because both of these are this, I'm just going to write this down as 3x squared plus 5x squared, because I don't really need to write it twice, Mr. Kamak. It is off topic, but will there also be a problem set after the test for this unit? Not for the first unit. So on Monday, you're just going to have a test. Not Monday, Tuesday rather. But on the next unit, so for this particular unit, there will be an assignment as well. Well, we'll get to that because we're way off from that. All right. Okay. So I'm going to have the 6x plus 5. Then I'm going to multiply that by 3x squared plus 5x to the power of 2. But guess what? I'm going to have this same thing 3 times, because remember, each of the terms is the same. So I'm going to have another 6x plus 5, right, multiplied by the same 3x squared plus 5x squared. Can everybody see that I'm going to have this same thing showing up 3 times? 6x plus 5, 3x squared plus 5x squared. Does it make sense when I say that I'm going to have the same result every single time? So you're right. And look at what Alexander just said, right? So it means that really I have 3 of these things. I have 3 do I have no, I don't have space up there. I'm going to put it down here. I'm going to have 3 6x plus 5s times 3x squared plus 5x all squared. So that's what, at the end of the day, when I put all of these same 3 things together, I'm going to have 3 of them. 3 times 6x plus 5, 3x squared plus 5x. So does that suggest a shortcut? It absolutely does. If I ever have a triple product, but it's really something cubed or something to the power of 4 or something, some other exponent, what could that maybe mean if I was trying to find a shortcut? Well, I will show you right now. The power of a function rule for integers says if u is a function of x, and I know it's not going to make sense right away, but we will make it make sense in a minute. If u is a function of x and n is an integer, so u to the power of n, then I'm going to have n times u to the power of n minus 1 times du dx. I'm going to take the derivative of the u and multiply by the exponent times the u to the power of n minus 1. Okay, what does that all mean? I'll show you right now. I'm going to go ahead. So can you imagine having to do this thing here with a 7 times? I mean, no, that's just scary. So here's what it's going to look like. It's going to be the product of 2 things. Notice that what you're looking at here is a product, right? So this is going to be a product. So I'm going to take this thing inside here as if this was just simply x to the power of 7. So that would mean that the dy dx would be equal to 7 times all of this thing here, 4x5. So this is the underived. I'm not deriving the inside at all. It's just 7 times 4x5 plus 2x minus 1 to the power of 6. Then I multiply that by the inside function, which would be 20x. Actually, I need more room for this, which would be 20x4. Sorry. Which would be 20x4 plus 2x. 20x to the power of 4, that is. Not plus 2x, plus 2, sorry. All right. So what I did is I just treated this thing as if it was an x squared, or really what is a u squared. I just derived it as if it was just x to the power of 7. So that would be 7 times this thing to the power of 6. Then I multiplied that by the inside function, which would be the 4x5 plus 2x minus 1 derived, which is 20x4 plus 2. This is a derivative that we're looking for. Okay, I could try this again. I'm going to copy this part down here. Right, so I'm going to just oh, sorry, I didn't mean to do that. I'm just trying to bring this thing down. Where did it go? There it is. Okay, so we're going to do the same thing with this function. So treat this part inside as if this was like a, think of this as being a 2 u to the power of 43, right? So this part in here is like your u function. So if I did that, then my dy dx would be, in fact, I'll keep that u there for now. So here's, you know what, let's think of it this way. Let's let u equal 4x minus 7. So I'm going to derive this as if this was 2 times u to the power of 43. That clearly would be equal to 86 times u to the power of 42. But then I have to multiply that by the derivative of the u. The derivative of the u is just simply 4. But now I have to put that u back into the equation. So the actual dy dx would be equal to 86 times, the u, remember, was the 4x minus 7, and then multiply that by 4. I need some help. What's 4 times 86? I can't do everything in my head. What's 4 times 86? Help me out. Actually, maybe I could do it in my head. 170. No, I can't. What's 4 times 344? Thank you, Alexander. So 344 times 4x minus 7 to the power, oh, I left something out, to the power of 42. Okay, there's your answer. That would be the derivative. Now, this is actually an application of something we call the chain rule, and we're going to do the chain rule in more detail in another class. But this is still using the product law, but also kind of sneaking in the chain rule as well. But we'll get to the chain rule in more detail in another class. Okay. How are we doing so far? All right. Thomas, how about you? Thomas, are you with me so far on this? Does this all make sense? All right. How about Vanessa? Vanessa, you're there as well? Following along, everything good so far? Okay, great. All right. Well, let's play around with this a little bit. Let's see. And by the way, the stuff we're about to do might actually help you out when we are talking about, dealing with the homework from last night. What if I were, this is another application of the chain rule again. What if I had a function like that, y equals 4x 5 plus 7? Any anything that we, okay, let's see now. Let me go back. Where does 86 come from? Oh, let's go back. Did I make a mistake there? I might have made a mistake. That's possible. That is absolutely possible. Where did 86 come from? Oh, 43 times 2. That's 86, right? 2 times 43. Oh, okay. Okay. So that question was answered. All right. Great. Perfect. All right. Thank you very much. All right. Any suggestions as to how I might want to tackle that question that's there? The square root of the 4x plus 5. Sorry, 4x to the power 5 plus 7. Any suggestions on how I might be able to put that together? Raises to the power of a half. There you go. So let's think of this as being y equals, and instead of using the u, and you're right, you can think of it as being u, but I'm going to just go ahead and put the 4x to the power of 5 plus 7 and raise that to the power of a half. Just remember, square roots as an exponent, thank you very much, Richard, and thank you very much, Adam, can be interpreted as being a half as an exponent. So we're going to use that same, it's really the chain rule that we're using here. So we're going to go ahead and take that half and multiply it by the whole function. So 4x to the power of 5 plus 7. Raise that to the power of minus a half. Then multiply that by the inside function, which of course is 20x4. Okay. Now, in terms of simplifying it a little bit, because I do like when you simplify them, think of it as being this. This 4x to the power of 5 should really be on the bottom. It's 4x, that's not 5. 4x. All right, that's ugly. Let me fix that. So this, first of all, there's a 2 on the bottom here, so I'm going to put that 2 in. Multiply that by, you know what? Multiply it by this, and hopefully it's going to make sense to everybody. Multiply that by the square root of 4x to the power of 5 plus 7. I'll see if that makes sense to everybody. And then on top, I'm going to put the 20x to the power of 4. All right? Which, by the way, I can reduce down because the 20 and the 2 are reduced down to 10. So it really should be this. 10 x to the power of 4 over the square root of 4x to the power of 5 plus 7. Okay, who have I lost? Is there anybody who isn't sure of what I just did there? All right, remember, to the power of minus a half means I should really put this part that's being raised to the minus a half as a denominator, but also because it's a half, it means a square root. And I just wrote it as a square root. The 2, 1 over 2, I put the 2 at the bottom. The 20x to the power 4, I put that on top. And I did reduce down the 2 and the 20. So that really is sort of a simpler way of writing that question down. Okay? Okay, so can we do both ways, right? It would be good. When you say both ways, what's the other way that you were thinking of? Tell me the other way you're thinking. Oh, you mean like leave it as it was before? Is that what you're thinking? Yeah, but in grade 12, you kind of want to jazz things up a little bit and try to put them in their simplest terms. So it'll be good if you were able to reduce it down. All right. Okay, next one. How would you tackle this one? 4 over 6x plus 1. Give me some thoughts on that. Give me some ideas on that. Again, try to put it in some format which has exponents in it, if you get my drift, right? What kind of exponents would be useful for this question? 4 over 6x plus 1. Is there another way I could write that? Can anybody think of an alternative way of writing that down? Again, this might apply to stuff you did on your homework last night. 4 times 6x to the power of minus 1. Thank you very much, Adam. There's a question sign. I don't know why there's a question sign, because you're absolutely right. That's the same thing as saying 4 times 6x plus 1 to the power of minus 1. The minus 1 means that you have taken it from the denominator and put it as a numerator, but the sign of the exponent has to change. Everybody clear on that? Does that make sense to everybody? All right? Just so I know it makes sense to Adam, but how about everybody else in the room? Tomaleo, how about you? Are you good with that, Tomaleo? You're good. Okay, perfect. So now we can use that same chain law again, because we can now say, okay, so dy dx, I'll just use f prime of x, is equal to the minus 1 times 4 is minus 4, and then the 6x plus 1 to the power of minus 2 times the 6, because I also have to take the root of the inside function. So what does this look like at the end of the day? F prime of x. I'm going to put this thing that was a negative on the top now, so it's going to be equal to the minus 4 times the 6 all over 6x plus 1 to the power of positive 2. Okay? We're putting it as a positive 2. So yes, it would be minus 24, but I think you're missing it should be over to minus 2, yeah. But Alexander, you're right, but I would prefer if you wrote it as a denominator, the way we have it right now, with a positive exponent. Okay? So this is what I would have. So here's my final answer. So yes, you're right, minus 24 over 6x plus 1 squared. Now remember, folks, I like it when you stop me and say, Mr. Kamal, can we just kind of put the pause button there, hit the pause button there, and just sort of talk about that next step there just a minute more? I actually prefer that to just sitting there if you don't get something and not say anything. That's courage, right? That's what I'm looking for. Students with the kind of courage to step up and say, you know what, I had to do that sometimes, right? And I'm encouraging you to do that as well. If there's something that doesn't click, you just let me know, right? Okay, let's try a few more here. Here's where we're going to use that product law again, right? We taught the product law before. So I'm going to rewrite this as, everybody should be able to appreciate this now, as a 2x, but I'm going to multiply it now by 4x plus 3. We've seen this before, to the power of a half, right? That's the same thing as a square root. And now we're going to apply the product law. Product law says, for my dy dx, that is, derive the first one. So this, I'm going to circle the first. There are two functions at play here. There's this function, and then there is this function. And they're being multiplied together. So the first function, when I derive it, would just be 2. Then I'm going to multiply that by the second function underived, which means it's still going to be 4x plus 3 to the power of a half. That did not change. But plus, I'm now going to derive, I'm going to first of all put back the first function as 2x. Right? I'm not deriving it this time. I know I'm going to derive the second function. And the second function derived would be a half 4x plus 3 to the minus a half times the derivative of the inside function, which is 4. Whoa, that's a lot of stuff to work through there. A lot of stuff to work through. So this is the equivalent of, I put everything in black now. I can still leave this as it is. So 2 times the 4x plus 3 to the half. But this second one here, the 4 times the 2 is 8 times a half is 4x times 4x plus 3 to the minus a half. And as I've been saying, I think the better way to write this would be 2 times the square root of 4x plus 4x. 4x plus 3, and then plus the 4x over the square root of 4x plus 3. Okay, I put the square roots back as square roots. All right, let me let that sink in for a minute. I have one other question to do on this page, but let me let that sink in for a minute. Okay, the other question I have is this one here. So let me copy and paste that down a little bit further. All right, so let's make that a little smaller first of all, then bring that down. Okay, I'm looking for some suggestions as to how I would tackle this one. Anybody, give me another way I could write this. Later on today, we're going to learn another law called the quotient law, which could also be applied to this, but I'm going to raise it to the power of -2. Thank you very much. Yes, yes, yes. Okay. So, or was that answer for that? I was trying to think of. Yeah, let's do that. It's going to rewrite this as the 5x on top, but then I'm going to write this as 6x plus 1 to the -2. Okay? All right. So let's keep going here. We're going to use the product law because we're taking the product of both of these. So my f prime of x would be equal to 5, because I'm deriving the first part, 6x plus 1 to the -2. I'm not deriving that second part, plus the 5x times -2 times 6x plus 1 to the power of -3. Okay, the first one, I'm going to rewrite that as 5 over 6x plus 1 squared. And then this part, I'm going to write this as being minus 10x. All right, the 2 minus 2 times the 5. And remember, this -3 is only the 6x plus 1 is only thing being raised to the -3. But sorry, how did you get that second part of the question? Thank you, Anika. Okay, so excuse me. Thanks for slowing me down, Anika. I want that. So let's see if maybe I made a mistake. So let's make sure I didn't do anything wrong. So there are two parts to this function: the 5x, and then there is this part right here. And those are two things we're multiplying together. So I'm going to derive the red circle first, which just gives me the 5, right? I'm going to multiply that by the underived second part, so the green circle, the 6x plus 1 to the -2. Then I'm going to take the 5x in the red circle and not do anything with it, so just simply 5x. And then I'm going to derive the second part, the green circle, bring the -2 in the front, so it's -2 times the 6x plus 1. Well, I'm missing something, am I not? I am missing something. Yeah, what am I missing from that second part, folks? Somebody said anything to me about that. What am I missing? The 6. Thank you very much. Yes, maybe that's what Anika was noticing. I should have multiplied this by the inside function, which is times 6. Right? That's missing actually. That's absolutely missing. Okay, so this is not to the power of 6. I don't want to mislead anybody. So let me tidy this up a bit here. Let me tidy that up a bit. So this, okay, actually, okay, so this is to the power of 3 right? When you derive this function here, so minus 2 times that to the power of 3, I'm going to close this off and then times this by 6. So Anika, I appreciate you sort of hitting the pause button there because I just realized that I left something out. So thank you very much. Is that more clear to you now? That makes more sense. Okay, great. Thank you. Yeah. You're good catch there. All right, so let's come back to this now. So that's not minus whatever I just said before was wrong. So now we're going to take, what is this now? Minus 12 times minus 60 is what I'm thinking right now. Minus 60x. Minus 60x. And all of that is over. Just make sure 2, 10. Yeah, okay. All of that's over 6x. This is minus. Oh, sorry. This is minus 3. That's another mistake right there. 6x plus 1 to the power of 3, to the power of positive 3. Yes, Adam. Yes, absolutely. Wow, you guys are sharp. Sharp as a tack. I got to tell. I got to give you credit for that. Really have to take my hat off to you if I had one on. All right. So it's actually minus 3. Okay. So we're about 10 minutes away from the break. Umair, how we look? How we stay here? So my Jamaican-ness is actually coming through there. How do we look, Umair? Look okay so far? Where's Umair? Where is Umair? Where are you, Umair? Okay. So you're understanding it so far then, yes? You're good so far. What we just did is fine. Okay, good. All right. So let's see what else we got here on the agenda here. Actually, I think, what's this other question here? No, that's something else. Yeah, I think we've just completed what I had to do on the product law, right? Now, I should mention that when you have a question like this, let me do one more thing before I give you guys a break. When you have a denominator like this, here's my expectation for you, that you should combine this into one denominator. And the correct common denominator for this, I'm just going to tell you, should be 6x plus 1 to the power of 3. That should be when you see two denominators like this, where they're both the same base being raised to different powers, you look for the higher power. So in this case, 6x plus 1 to the power 3 would make sense. Then we're going to ask, what would you multiply this denominator by to get this denominator? The answer would be 6x plus 1. So it would be 5 times 6x plus 1. And then just simply minus 60x. Right? And it is important for me to show you this because I do expect you to do this and carry this through and simplify it as much as possible. I remember Nico was asking, I think it was Nico was asking, is it okay to leave it in the other format? No, I really prefer if you try to simplify it as much as possible. And that's what is involved in what we're doing now. Right? So hopefully what I just did made sense. What am I multiplying this denominator by to get this denominator? Is actually 6x plus 1. So 6x plus 1 times 5. And then what I multiply this denominator by to get this one is just 1. So the top is just going to be same 6x. So then I can combine them into 1, which would be, what is this? Now this is 30x plus 5 minus 60x divided by 6x plus 1 cubed. And of course, one more little step here, which is to make that minus 30x plus 5 all over the 6x plus 1 cubed. So my expectation is that you can, on a test, if I gave that to you and asked you to simplify it as much as possible, that you would make that last step to get full marks. Really, it's obvious that this format is much more succinct and much more concise than this answer here. All right. I mean, it's not that it's wrong, or this answer here, I should say. It's not that it's wrong. It's just not as simplified as much. And that's an expectation that I do have of you.